Hey everybody, Mrs. McGuire here, getting ready to get into some trigonometric ratios today with you. And this is pretty exciting because this is more of what's important for your pre-calculus. Hopefully you have this worksheet right in front of you, so let's dig in and get this party started. You're going to notice, first of all, here I have written out your three trig functions that we're going to start. And these are the three most basic. There are actually 6 trig ratios, and you'll learn the other 3 when you take pre-calculus. But we are starting you off with these. And we have sine, cosine, and tangent. And you're going to notice that there is this weird shaped thing going on here. This is a Greek letter of the alphabet called theta. And Greek letters are used as variables. So instead of having like a blank angle there or an X or a Y, we use a theta. And theta is typically used to denote the angle measurement. And so you're going to notice that we have, well, I'll use the theta from time to time, but that's what you're going to see typically when you get into pre-calculus is more Greek letters showing up for you. Don't be afraid of them. They're just letters and they're just variables for us to use. Alrighty, so we are going to look at ratios and ratios according to our right triangle. So there's a lot going on here. And you're going to notice up at the top it says SOHCAHTOA for right triangles only. And this is a mnemonic device that's going to help you remember your ratios. So the first thing you're going to notice is we've got opposite leg, hypotenuse, adjacent leg, hypotenuse, and opposite leg and adjacent leg. You know what the hypotenuse is. But when you're looking at the triangle, you have to know which angle you're focused on. So for our first 3 examples, and these are the abbreviations for sine, cosine, and tangent, this is not the word sin. Right? This is an abbreviation for our sine ratio. X is the angle that we're going to focus on. So over here on my picture, let's highlight that angle because it does make a difference, the angle that you're focused on. Now, the hypotenuse of your triangle is not going to change. Your hypotenuse is your hypotenuse is your hypotenuse, and that's the side opposite the right angle. So we've got our hypotenuse is ZX, and it's got 40 units on it. Our opposite side is considered the side that is not part of the angle, right? So when you look at angle X, you've got XZ is one side of our angle and XY is the other side of the angle. The part of the triangle not touching is the opposite side, and that's CY. So I'm going to label this a little OPP for opposite side. And then adjacent to the angle is the side of the angle that's not the hypotenuse, right? So the hypotenuse is an adjacent side, but it's more specialized. It's the hypotenuse. So this is going to be known as our adjacent side. And this is all because we're looking at X. So when I ask you for the sine of X, you're going to go ahead and give me this ratio, the opposite leg over the hypotenuse. So that would be 32 over 40. And of course, it's a ratio. You're not going to leave it as 32 over 40. That's reducible by 8 and gives us 4 over 5. All right. And you can also see that up here in our little mnemonic device, SOH, this is the sine function is the opposite side over the hypotenuse. That's your ratio. All right, so next comes cosine, and this is the adjacent over the hypotenuse. So cosine is adjacent leg over hypotenuse. That's the CAH. And so down here, doing the cosine of X, we're going to do the adjacent side, 24, over the hypotenuse, 40. And that's going to reduce down to 3. This. Pretty nice, huh? And then the last part, tangent. Tangent is your opposite leg over your adjacent leg. That's the TOA. T is for tangent, O is for opposite, A is for adjacent. And so from X, Opposite is 32. Over our adjacent side is 24. So we're looking at 4/3. Now this is a ratio. Do not make it a mixed number. It's kind of like when you had slope ratios and you use slope. We use trig ratios to relate sides of a right triangle. So don't make it 1 and 1/3 because then now you're not talking about the sides and how they relate on the triangle. So leave it as the 4/3. Now you might have noticed, hopefully, that we've been reducing every single ratio. And we've talked about Pythagorean triples, but one thing that you could do is go ahead and reduce your whole triangle right from the get-go, right? So you could go ahead and 40, 32, and 24 are all divisible by 8, right? We could divide everything by 8, and so we could work with a 5, a 3, and a 4. And you could do that in the beginning, and yes, you're probably going, or maybe you already saw that it was a 3, 4, 5 right triangle. Nice Pythagorean triple. All right, I am going to give you a moment. I'd like you to try out the triangle below, and this time on our triangle below, we're going to go ahead and focus on Z. So we're changing what we're doing. So what changes when we do this? The hypotenuse is going to stay the same, but I want you to answer this question. What's going to change with the relationship here? Do you see what's happening? It's because we changed our angle, right? And X and Z, these are angles that are complementary in nature, right? So when we switch those, we are actually changing the opposite side and the adjacent side, because now XY is going to be considered my opposite side, and now ZY is adjacent. All right, so take a moment and fill in sine of Z, cosine of Z, and tangent of Z. And don't forget to reduce. All right, so now that you have those answers, and I don't have mine written down, so for the sine of Z, you should have gotten 3/5, right? Because we're doing the opposite over the adjacent. Let's go ahead and reduce these, right? We already know, because it's the same triangle that I gave you before. So we've got 3/5. And notice that the cosine of X and the sine of Z, right? Because those sides, those angles are complementary in nature, and the opposite side and the adjacent side flipped. So cosine of Z is going to be the same thing as the sine of X. It's the 4/5, right? Because cosine is going to be your adjacent side over the hypotenuse, the 4/5. And then tangent, the opposite and the adjacent change. So for tangent, you should be getting the reciprocal, the 3/4. Nice. Great job. All right. Number 1 below, we have a different triangle down there for you. And I'm going to let you go ahead and try that out. Go ahead and find the sine of angle A. And we're looking at angle A here. Highlight that. The cosine of angle A and the tangent of angle A. Okay, so hopefully you labeled your triangle. You know, you're brand new to this, and don't think you got it all just like that. Go ahead and take the time, especially when you have your test coming up, which should be next week sometime. So we're going to have our hypotenuse, our opposite side, and our adjacent side. And then we're going to follow sine is the opposite leg, 15 over the hypotenuse. So it's just 15 over 17. No reducing on this one, right? This is already a nice little triple. Cosine is the adjacent side over the hypotenuse, so 8 over 17. And tangent is the opposite side over the adjacent, so 15 over 8. All right, we are going to dig down and look at trig functions. And this is really, when you start pre-calculus and you get into your trigonometry, you are going to be looking at the 45, 45, 90-degree triangle, and you're going to know, you're going to memorize the sine, the cosine, and the tangent. So what's interesting here is that we're looking at the legs, right? The legs are exactly the same because it's a right isosceles triangle. And you already know this relationship of x, and x square root of 2. Now, I'm not going to put in any values, but we could have values on this triangle, right? This could be like 3, 3, and 3 square root of 2. But watch what happens as we work with the x's. Watch what's going to happen. So let's just say that we're going to focus on this 45-degree angle. All right, so that way, if we focus on this angle, we can establish, we know our hypotenuse, the opposite side, and the adjacent side. All right, so for sine from this angle, we're going to do the opposite over the hypotenuse, which is x over x square root of 2. Now notice what's happening with the x's. The x's are going to cancel. Isn't that a cool thing? So that means that no matter what I had put in there for the legs, it wouldn't make a difference because it would be canceling out right now. So we'd get 1 over the square root of 2. And I know you're not leaving an answer like that. You're going to rationalize it. So we're going to multiply by the square root of 2 over the square root of 2. And we'll get the square root of 2 over 2. That's the sine of any 45-degree angle on any triangle. Pretty neat, huh? And I think this helps answer some questions for you as to why we just need the angle measurement. Why don't I need to know the sides? Why does this always work? And I think these special right triangles help you to see the relationship happening. All right, I'm going to give you a moment. You go ahead and try the cosine of the 45 degrees. All right, how did it go? Oh my goodness, did you get the same answer? Why is that? Because the opposite and the adjacent side are the exact same value, right? They're both x. So when we go through this process and we're doing cosine, we're going to do the adjacent side, which is x, over the hypotenuse. And you notice it's x over x square root of 2. So I'm hoping that you notice that these are identical. And I mean, yes, we could work through that, but we're going to end up with the same answer. Square root of 2 over 2. And that's for any 45-degree angle. The cosine of every 45-degree angle is square root of 2 over 2. All right, you try tangent. Okay, so tangent's even easier. Did you know how to reduce it? Sometimes this freaks people out a little bit. So tangent is the opposite side, x, over the adjacent side, x. So you're looking at x over x, which reduces to 1. That's pretty cool, isn't it? All right, let's go on to our next special right triangle that we've been working with, our 30, 60, 90. All right, so this is the last thing that you did for homework. And so we're going to take a look at it. And again, we're working with the variables x, 2x, and x square root of 3. And it's all labeled. It's so nice, isn't it? So first, we're going to look at the 30-degree angle. When we're doing the 30-degree angle, here I'm going to put this in blue. So 30 degrees, this is always going to be our hypotenuse. But right now, x is opposite here. So this is your opposite side. And x square root of 3 is your adjacent side. So for the sine of 30 degrees, we are going to do x over 2x. And that reduces to 1 over 2. Very nice. For cosine of 30, we're going to do adjacent over hypotenuse. So we have x square root of 3 over 2x. And the x is reduced, so you do get the square root of 3 over 2. And then finally, tangent is opposite over adjacent. So that's x over x square root of 3. So you are going to get 1 over the square root of 3, and we're going to rationalize that. So we have the square root of 3 over 3. All right, and again, when you guys take pre-calc, you are going to memorize these. These will be something that you learn on your unit circle. All right, so now we're going to switch gears, and I'm going to give you a moment to try each of these before I run through them. And hopefully you're noticing some relationships happening, but this time we're going to focus on this 60-degree angle, and I'm going to do this one in pink. So now, since we're switching to the other complementary angle on our triangle, the adjacent and the opposite are switching. So now for the pink, x is my adjacent side, and x square root of 3 is my opposite side. So we're trading places here. So you go ahead, you find the sine of 60. All right, how'd that go? Did you get the square root of 3 over 2? Did you remember that it's going to be the cosine of its complementary? All right, so let's take a look at this. So 60 degrees, sine is opposite over hypotenuse. So we're x square root of 3 over 2x. So the x's will cancel out, and we get square root of 3 over 2. Cosine is going to be the sine of 30, or 1/2. I didn't give you a chance to try that. That's okay. So cosine is going to be the adjacent side, the x, over the hypotenuse, the 2x. So that's 1 over 2. All right, you go ahead and try tangent. Right, so tangent of 60, it's going to be the reciprocal of the tangent of 30. So coming back up here, because the opposite and the adjacent switch, we're going to do x square root of 3 over the x. And you can see it's the reciprocal, right? The x and the square root of 3 have changed. So this is just the square root of 3. Awesome. All right, for this next section, we are going to use our trig functions to find missing side lengths in a triangle. And you are going to use a calculator. I have a calculator here. Let me just show you. This is my sine, cosine, and tangent functions on my calculator. And hopefully you have one that's a little bit newer. If you have an older one, it's going to be input the reverse of mine. But if you have one that's newer that has a solar display, you should be fine. And it should work just the way mine does. A graphing calculator is fine. That's great. If you're struggling with your calculator, bring it to our live chat or bring it to Helps class and I can help you with it. All right, so let's take a look at number 2 and look at the problem here. You're going to know that you're using the calculator because look at the directions. Find the missing side length of each triangle. Round your answers to the nearest 10. So we're not working in fractions or ratios like we were with the other problems. We're going to round our answers, and that should clue you in that you need a calculator. All right, so we're still going to use our trig ratios. When you look at number 2, and we're looking to find DE, let me just put a little variable on it, right? We're looking to find DE. You want to ask yourself, all right, so I'm using this angle F that's 39 degrees, and look at what you're given. You're finding the opposite side, and you have the adjacent. So which trig function is using the opposite side and the adjacent side? Yeah, we got to use tangent. So let's write that out. This will help you get to know your trig functions. Don't be lazy, write these out. So the tangent of an angle theta is going to equal the opposite side over the adjacent side. And then we're going to plug in what we know. Our angle measurement, the 39 degrees, is going to go in for theta. That's our variable for angles. So we're going to do tangent of 39 degrees equals our opposite side over the 20 meters. All right, now when you look at this, I hope you're looking at it like a proportion. Because the easiest way to solve this, like you could multiply by 20 meters on both sides, or you can just put a 1 underneath here and do cross products. These are the easiest because you have 1 times x, right? 1 times x is just x. So you have tangent of 39 degrees times your 20 meters. And so now it's calculator time. So I'm going to bring the calculator into the picture so you can see me working on it. Really look at the screen here. And let me turn it on, just clear it out there. So one of the things that you're going to notice on my screen is that I have this little DEG. It's really important that your calculator is in degree mode. Degree mode is different than radian measure, and you will learn about radian measure. That's another way to measure an angle, and your calculator knows both of them, even though you don't yet. But for right now, we're just going to use degree mode. So again, if you don't know how to change this, you can bring your calculator to Math Helps, or bring it to our live class, and I can help you at the end of one of those 2 sessions and fix your calculator up. But it's really simple. I am going to press tangent because that's the trig ratio I'm working with. I'm going to put in the 39, go ahead and close up the parentheses, and you can go ahead and push times 20, and it does the entire thing for you. So the length that I am missing, and it said round it to the nearest tenth, so that's 1 placement after the decimal, so we're going to round up because the 9 is in the hundredths. So it's going to be 16.2 meters. That's our answer. And then make sure your answer makes sense. All right. So your answer should make sense. This is 20 meters, and you know that this angle is smaller, right? Because this other angle, if this is 39 degrees, the other angle should be what? What should the other angle be? Angle D, right? It should be 51 degrees. So you know that if this angle is larger, it will have a larger side opposite sides, right? So the 39 degrees is smaller, so it makes sense to have a smaller side. So just make sure that your triangle makes sense when you're looking at your answers. Okay, let's go on to another 3. I'm going to pick a new color to work with. And the first thing I want you to do is look at your triangle, label what you're working with, what you're asked to find, and figure out the trig function that we're going to use. All right, so when I look at this triangle, I am asked to find RQ, all right, which is a little bit longer than QP, so it seems. But I have the hypotenuse, and I have from this angle that I'm given to work with, the 63 degrees on P, this is my opposite side. So hopefully you said sine, right? We're going to do the opposite over the hypotenuse. So this is sine theta equals opposite over hypotenuse. Okay, so let's plug in what we know. We've got the sine of 63 degrees. The opposite side is the x variable, and the hypotenuse is 12.9 centimeters. Okay, so I like to look at these as little proportions. I'm going to put a 1 under here. I've got 1 times x equals sine of 63 degrees times my 12.9 centimeters. And now it's calculator time. All right, so let me grab the calculator again. And degree mode, if you're in degree mode, you don't need to change anything. Even when you turn it off, your calculator is going to stay in the mode that you set it to. It's not going to default to anything else. So we are going to do sine function this time, and you can see it shows up in my display. Be careful when you're working with your calculator. Make sure you're checking that display all the time, because sometimes we're like so lackadaisical because we're like, yay, we get to use a calculator, and then we push the wrong button and we get the wrong answer. So don't do that. All right, so 63 degrees, putting that and closing off the parentheses, and then times the 12.9 centimeters. And there we go. We're rounding to the nearest tenth. So x is 11.5 centimeters. And let's go look at our answer. Make sure that it makes sense. We had 63 degrees, so we're looking at 27 here. It's definitely smaller than the hypotenuse, right? The hypotenuse is the largest side, so it makes sense. And 63 is not that much smaller than 90, so that's why it's only a little bit smaller. Okay, last one on the notes. You're doing a great job. Go figure out the trig function. Do it. Okay, so looking at the 51 degrees that were given, 17 meters, or FE, is my opposite side again, and I am finding FD, which is my hypotenuse. So again, we're using the sine function. So we're going to write out here the sine of theta equals opposite over hypotenuse. And this time my angle is 51 degrees. And the opposite side is 17 meters. And my hypotenuse is x. So I'm really glad to pay close attention that we're doing this together. This one is a little bit different. The x is in the denominator of my proportion this time. And so when I do cross products, I don't have the 1 times x. So watch what's going to happen. We have x times the sine of 51 degrees. No problem. Equals 1 times 17 meters. All right, so here's the crazy thing. This is x times the sine of 51 degrees. We want to get x alone. We're going to divide by the sine of 51 degrees and do it on the other side as well. Okay, so these cancel out. Sine of 51 over sine of 51, that's a 1. And now this is calculator time. In your calculator, you're going to do the 17 meters divided by the sine of 51. And here's what it will look like. Clear it out. So we're going to do sine, not sine, I'm sorry. See, be careful. 17 divided by the sine of 51. Close it out your parentheses, and voila. We're getting 21.9 or 9/10. We're rounding to the nearest tenth. And those are meters. And then let's go back. Does this make sense? It should, because this is our longest side, right? This is our hypotenuse, so it definitely should be bigger than the 17. All right. Great work, my dears. Have an amazing day, and go get your homework done. Love ya. Bye-bye.